Good morning everyone. My name is Shanti. I am going to do digital communication subject. Today our topic is pulse code modulation technique. Before going to this topic, let us discuss about what we mean by modulation. As we had already discussed about modulation, it is a process in which some of the characteristics of the carrier signal gets varied in accordance with the instantaneous amplitude of the message signal. Now, PCM, we are going to discuss about what is the PCM, what is the quantizing process, and number of quantizing levels that has been assigned in PCM. So we have already known that pulse modulation techniques or pulse modulation systems are classified into two. Those are pulse analog modulation and pulse digital modulation, we call it as. So pulse analog modulation systems are classified or includes PAM, PPM and PWM. PAM specifies pulse amplitude modulation, PPM specifies pulse position, and PWM specifies pulse width modulation techniques. So PAM, PPM, PWM are digital, but rarely binary, as a pulse does not represent a single binary digit. So pulse digital modulations includes delta modulation and PCM modulation techniques, we call it as. So pulse analog means there will be variation in the amplitude of the pulse, variation in the width of the pulse, variation in the position of the pulse. Now pulse digital modulation techniques means whatever the information that has been converted in the binary form, either 0 or 1. So those terms are pulse digital modulation techniques, we call it as, and it includes PCM and delta modulation. This pulse code modulation stands for that is PCM stands for pulse code modulation. It is a digital modulation technique. A digital modulation scheme is a technique which the information is converted in the pulses and expressed in binary format, that is in bits, either zeros or ones. Now, it was developed by AT&T in 1937 at Paris Labs by Alex H. Revis, we call it as. He is a scientist. He invented this technique, and it was developed by AT&T in 1937. It is a form of source encoding rather than the modulation technique. PCM uses the sampling technique similar to analog modulation schemes. So generally, pulse digital techniques undergo three processes. Those are sampling, quantizing, and encoding. So generally, a sampling means it is a process in which a continuous signal is converted into discrete form of pulses. So discrete. So continuous signals, or it is a process in which analog signals are converted into discrete pulses or discrete signals. After sampling, we are going to undergo a technique which is known as quantization. Quantization is a technique of assigning voltage levels to sample signals. After assigning voltage levels to the sample signals, that is given to encoder to convert that voltage levels into binary format, either zeros or ones. So PCM uses a sampling technique similar to analog modulation schemes. Now, in PCM, the message signal is sampled and the amplitude of each sample is rounded off to the nearest one of the finite set of allowable values. So, what does it mean is, in PCM, in PCM, the message signal is sampled and the amplitude of each sample is rounded off to the nearest one of the finite set of allowable values. So, here what we will do is, whatever the sample signal that has been assigned the voltages, let us suppose that let us suppose you are taking a sample signal that has voltage levels of 4.5 or 4.6. In that way, if you have the voltage levels, 4.5 is assigned to 5 voltage. So that assigning of signals to the rounded values to the nearest one of this finite set of allowable values, we call it as. In PCM, both time and amplitude. In PCM, both time and amplitude are in discrete form. In this scheme, the signal is represented in binary form, that is bits either zeros or ones. In US, PCM is the preferred method of communication within public switched telephone network. This allows the message signal to be transmitted by means of coded electrical signals. The available range of signal voltage is divided into levels and each is assigned a binary number. So here what it means is, whenever you are taking a sampling, after sampling that has given to quantization, from there it is given to encoded signals. So in US, PCM is preferred method for public switching telephone network. This allows the message signal to be transmitted by means of coded electrical signals. The available signal voltages are divided into levels and each is assigned a binary number. So this will be in US. So pulse code modulation, the waveform pattern of pulse code modulation is standard values or the range of standard values that has given 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and coded values are assigned. So these coded values are based on the sample signals. So whenever you are taking coded values, it will check either the data has been delivered. So what it will check is coded values has been specified, that is they will sample, quantize and encode. These levels are separated by equal voltage gradations. As explained above, the signal is sampled, quantized and coded. Coding is assigning binary bits to the quantized levels. So what is meant by quantizing? Quantizing means after taking a continuous signal, that is at a sample, after converting the continuous signals into discrete pulses, those pulses are assigned with a predetermined voltage levels. So the assigning of voltage levels to the sample signals is termed as quantization, we call it as. The technique is now termed as quantizing and the process is known as quantization, we call it as. The next step after sampling is quantizing. The process of assigning voltage levels to samples is known as quantizing, we call it as. As the original signal has infinite number of signal levels, quantizing is used. Now in pulse code modulation, they had given you the waveform for that, where a quantized levels has been taken. Quantization means a step, that is nothing but a step voltage will be assigned, voltage levels will be assigned to the sample signals. The number of quantizing levels depends upon the number of bits used to express a sample value. So number of levels is given by n is equal to 2 power m, where n is the number of levels, m is the number of bits per sample. So the number of quantizing levels depends upon number of bits. Let us suppose that two bits are taken. So how many number of levels will be there is 2 square, 4 levels will be there. If the number of bits per sample are 3, that is the number of levels will be 2 power 3, that will be 8 levels will be there. So in that way the number of levels will be taken, that is n is equal to 2 power m, where m is the number of bits per sample and n is the number of levels that has been given on the screen. Quantization of signal for PCM. So actual signal is given solid line, quantized wave is given as dotted lines, we call it as. So total signal amplitude range that has been taken up and levels actually sent. So quantization specifies assigning the voltage levels to the to the sample signal that has been given. So this is quantization with respect to time. They had given more the number of samples, less is the quantization error. So these two are indirectly proportional to each other. That is, as the number of samples goes on increases, quantization error goes on decreases. If the actual signal is compared to the quantized signal, we can observe that it introduces some noise called quantization noise. So generally we had gone to noise. Noise is quite random, as the difference between the digits sent and the actual signal at that instant is completely unpredictable. So quantization noise is when you are comparing the quantized signal and the actual signal that has been transmitted, we can observe that some noise has been occurred, which is termed as quantization noise, we call it as. So noise is quite random, as the difference between the digits and the actual signal at that instant is completely unpredictable. The biggest error is equal to half the size of sampling interval. Quantizing noise can be reduced by increasing the number of levels until noise level is acceptable. So this is about quantization noise. Quantization noise means the difference between the actual quantized output and the actual output that has been given. The difference between that is termed as quantization error or quantization noise, we call it as. This quantization noise can be reduced by increasing the number of levels. In the number of levels. They had given you quantization noise that has been target timestamp and the quantization error. It is a step-by-step procedure they had taken. Random sample is given by round and synchronous sample is given by other symbol. The red color indicates the presence of quantization noise in the signal, shown with green color. So samples before quantizing and samples after quantizing they had given you with respect to time and original quantizing levels. So if you see on the screen, for samples before quantizing, you can observe that so when you see on the screen for samples on the screen, if you see here that levels has been raised, here they are fixed, assigned values has been given. So this is nothing but whenever you had taken the data, so in this way what we are doing is quantization levels on the screen. If you observe, you have this makes a flat top samples, that is nothing but before sampling. Imagine that we had taken a sample values as 4.5, 4.2. That 4.5 is assigned as 5 volts and 4.2 is assigned as 4 volts. So that will be done in the quantization process. Quantization means it is a process in which we will assign certain voltage levels to the sampled values or sampled signals, whereas encoding means this assigned voltage levels will be converted into binary form. So before sampling, if you observe at 4.6, 5.8, in that way you'll have those will be assigned or predetermined to 5 volts. In that way you'll do. That is nothing but before quantizing and after quantizing. Now let us discuss about quantization, quantization error and quantization noise. So what is meant by dynamic range? The range of PCM, dynamic range of PCM is a ratio of strongest possible signal that can be transmitted to the weakest signal that has been transmitted. So dynamic range of PCM is the ratio of strongest possible signal to that can be transmitted to the weakest signal. PCM is a PCM in which the levels are separated by equal voltages is called linear PCM. We call it as PCM in which the levels are separated by equal voltages is termed as linear PCM. So dynamic range an example of 4-bit sampling of a signal shown in the red color. This image shows that 16 possible values can be made from 4 bits, a very low dynamic range needed. So as we all know that m is equal to 2 power n, that has been given, or the number of levels, if the number of bits are 4, the number of levels are 2 power 4, that is 16 levels will be assigned. So in linear PCM, that is generally the dynamic range of PCM is the ratio of strongest possible signal to that can be transmitted to the weakest signal. In linear PCM, the quantization levels are separated by equal voltages. In linear PCM, the maximum dynamic range in decibels is given by dynamic range is equal to 1.76 plus 6.02 m decibels, where m is the number of bits per sample, we call it as. So generally the data rate in bits per second D is given as Fs into m, where Fs is a sampling rate in samples per second, M is the number of bits per second. So increasing the number of bits per sample increases the data rate given by D is equal to data rate in bits per second, Fs is sampling rate in samples per second, M is the number of bits per second. So what do you mean by bit rate? It means how fast the work is happening with respect to time. So generally bit rate specifies that the amount of data, specifically bits, transmitted or received per second. Bit rate is given in terms of kilobits per second or megabits per second or gigabits per second. So now what makes the difference between bit rate and baud rate? So generally bit rate is the number of bits transmitted per second. Baud rate is the number of symbols transmitted per second. Relation between bit rate and baud rate is given by C is equal to log n by s2, where C is the capacity in bits per second, S is the baud rate in symbols per second, M is the number of possible states. So here before going to this pulse code modulation, one second. Now coming to the pulse code modulation, we had gone through what is the definition for pulse code modulation. So what happens in pulse code modulation is you'll have a sampler, quantizer and encoder. Okay. It is most commonly used in modulation technique. Each sample is represented by the binary numbers. The major stages involved in the process of PCM are sampler, quantizer and encoder, we call it as. So sampler, what it will do is it samples the incoming message signal using a sample and hold circuit. So generally you'll have the block diagram for PCM. Among that what you will do is you'll have sampler, quantizer and encoder. So sampler samples the incoming message signals using a sample and hold circuit. So what is meant by sampling? Sampling means converting the analog signals into discrete oral signals. That is sampling the input signal to produce PAM signal. So in PAM, the output in PAM what we are doing, the input signal, that is message signal, is sampled at regular intervals and the amplitude of each sample is made proportional to the amplitude of the message signal, we call it as. So generally what we will do is we will take the data that has to be converted into digital format or the digital that is digital encoding will be done. So generally the message signal that has been given is given to PAM, that will convert into that is converted into pulse amplitude message signal that is given to the quantization, where you will have a binary encoding will be done, and that is given to digital to analog, that is digital encoding technique, we call it as. So quantization is a process of assigning voltage levels to the samples. So what we already had discussed, that assigning voltage levels specifies based on the bit rate, we will maintain certain threshold levels, and based on threshold levels voltage levels will be indicated. So that voltage levels assigning is termed as quantization, we call it as. Encoding is a process in which sample voltages, that is quantizer output, are converted into digital equivalent. Analog to digital converters perform it. If there are 256 quantization levels, those can be coded by 8 bits. So generally what happens in coding and decoding of PCM is so this is introduction of PCM, we call it as. So here they had given in the block diagram, they had given in the waveform how a quantizing technique will take place over the pulse signal. The number of quantizing levels depends upon the number of bits used to express the sample value. Already we had discussed that number of levels depends upon the number of bits. If the number of bits are 2, the number of levels are 2 square, that is 4. If the number of bits are 3, the number of levels are 2 power 3, that is 8 levels. The number of bits are 4, 2 power 4, that is termed as 16 bits, we call it as. So now the process of converting this analog signal into PCM signal is called coding, we call it as. So generally you have coding and decoding of PCM, where how PCM has been coded and decoded will be learned. So process of converting this analog signal into PCM signal is termed as coding, we call it as. The process of converting digital signal into analog signal is called decoding, we call it as. So A to D converters and D to A converters will be there, where analog signal will be converted into digital signal at transmitter part, that is termed as coding technique, we call it as. At the receiver part, this digital signal whatever that has been delivered will be converted into analog signal, that is converting from analog to digital is termed as coding. Converting digital to analog is termed as decoding, we call it as. So coding and decoding process is obtained by using single integrated circuit, and that circuit is termed as codec, we call it as. So coding and decoding will be done using a single circuit board or single integrated circuit called codec, we call it as. Okay. So generally, what does the coding of PCM consists is, you'll have a message signal that is given to an anti-aliasing low pass filters, then sampler will be there, quantizer, encoding levels, and parallel to serial converters will be there. Now, what what does each level will do? As you have, will convert the data into a record form. So, in the process of converting the analog signal into PCM, what we will do is, initially the message signal which is analog in nature is given to anti-aliasing low pass filter. So generally, when you are going through a digital communication or digital modulation techniques, sampling is a process in which what a sampling will do is, will convert the continuous signals into discrete pulses. So whenever you are taking that discrete pulses, sampling theorem states that we have to accept the criteria. That criteria is termed as Nyquist criteria, we call it as. Fs greater than or equal to 2 times of Fm should be applicable. So whenever this Fs greater than 2 times of Fm has been applicable, it specifies that the original data can be recollected or reconstructed with minimum type of distortion. Okay. Now, the message analog signal is given to anti-aliasing low pass filter, where anti-aliasing low pass filter specifies that it should follow the sampling theorem principle, that is Nyquist criteria has to be followed. If Nyquist criteria has been not obtained, not applicable, that is if Fs greater than or equal to 2 times Fm condition is not acceptable, then what happens is the data that has been delivered will have a maximum of noise, which is not worthful. So what we will do is, we will use anti-aliasing low pass filter, where only low frequencies will be allowed, and anti-aliasing specifies that aliasing effect means if signals has not satisfied the Nyquist criteria, there exists one type of noise which is termed as an aliasing effect, we call it as. So if once the aliasing effect occurs, it cannot be removed. So that is the reason what we will do is, we will take anti-aliasing low pass filters, that is given to samplers. So sample and whole circuit, as we all know, a sample, it maintains a timing pulse samples, and then it holds for certain instant of time. So this is nothing but sample and hold circuit, we call it as. In this session, what it will do is, it will sample the signal. So in this session, to sample the incoming message signal using the sample and hold circuit, now to ensure the perfect reconstruction of the message signal at the receiver. The sampling rate must be greater or twice the highest frequency component of the signal, message signal, we call it as. So here, whenever you are going through that sampling, one second. So here what we are doing is, before quantizing we will have sampler. So when we are sampling specifies that we are using certain low pass filter and the data will be sampled. So after sampling, that is what it will do is, a condition Fs greater than or equal to 2 times of Fm has to be satisfied. So if Fs greater than or equal to 2 times of Fm, this is nothing but sampling condition, we call it as. Once all the information that has been obtained, you should accept this Fs greater than or equal to 2 times of Fm. If it satisfies, then there won't be an effect, which is a drawback, won't be there, that is termed as aliasing effect, we call it as. That obtains if Fs less than 2 times of Fm, a condition exists which is termed as aliasing effect, we call it as. In order to avoid this aliasing effect, we will use anti-aliasing low pass filters, so which allows every signal that will be obtained, that will be maintaining the Nyquist criteria. Then you will after sampling, you will have quantizer. The process of assigning voltages to the samples is termed as quantization, we call it as. Since the original signal have infinity number of signal levels, when the quantization is used, it assigns samples to any of the allowable quantization levels that are closest to it. So based on the information that has been assigned, we will maintain this quantized PAM signal. So the output of the quantized PAM signal. So uh, what we will do is encoding is a process in which the sample voltage, that is quantized outputs, are converted into digital equivalent. Analog and digital converter performs it. So the number of quantization levels available depends upon the number of bits used to express the values of sample. The number of quantization levels are given by n is equal to 2 power m. So already we had discussed this encoding process. Before that, quantization of the PCM include the more the number of samples, the less the quantization error. So more number of samples, less the quantization of error, which specifies indirectly proportional to each other. So based on that, the number of samples, the more the number of samples, the quantization levels, the quantization error gets reduced. So what is meant by quantization noise? Quantization noise means quantization noise specifies that whenever you are transmitting the data, the actual data will be compared with the quantized signal. We can observe that it introduces some type of noise which is termed as quantization noise, we call it as. So this quantization noise should be removed. Noise is quite random, as the difference between the digits sent and the actual signal at that instant is completely unpredictable, we call it as. So quantization noise specifies that during the quantization process, it will produce some errors, and that errors are termed as quantization errors or quantization noise, we call it as. So it occurs between the difference between the input signal and output signal. So let us suppose that a different signal can be recorded as noise, and it is called as quantization noise. So this can be decreased by increasing the number of quantization levels. So quantized signal with added quantized frequencies will be there. One second, that has been. This is a pulse code modulation quantization technique where we have taken along with the signal. See here the number of levels that has been given. Prior to home, we are discussing about quantization and quantization error, that is quantization noise. So noise has greater effect on techniques. So original quantized signal how it will be, and the quantized signal with added noise, there will be a variation in the signals. Is the quantization error based on the random sample that has been given and the synchronized samples they had given you. So based on that, the data will be generated. So whenever you are going for quantization noise, the red color indicates the noise that has been obtained, and that is in the presence of quantization noise. The signal, which is the signal is shown under green color. You have signal and you have signal levels that has been assigned. That is, the red color indicates the presence of the quantization noise in the signal shown with green color. So before time sample before quantizing and samples after quantizing, they had given you after quantization technique. All the samples are predetermined or based on the voltage level that has been assigned. So let us discuss about quantization error. Quantization noise one more time. Quantization, it is a process of assigning voltage levels to the sample signals. Quantization error means during the quantization process it produces certain errors. Those errors are termed as quantization errors. We call it as this quantization error consists of the difference between the input signals and the output of the quantizers. The difference between those two is recorded as noise and is called quantization noise. We call it as. So quantization noise is given by EM of t minus EMQ of t, where EM of t is the actual signal, that is message signal that has to be transmitted. EMQ of t specifies quantizing signal. Quantization noise is decreased by increasing the number of quantization levels. The error occurred during the process of quantization is termed as quantization error, or the difference between the actual signal and the quantized signal is termed as quantization error. We call it as. So dynamic range means the dynamic range of the PCM is the ratio of strongest possible signal to the weakest possible signal that has been transmitted. So in linear PCM, the quantization levels are separated by equal voltages. So the quantization levels will be separated by equal voltages. In the PCM, that is linear PCM system, maximum dynamic range is given by 1.76 plus 6.02 meters per decibel. So here on the screen they had given you what is the range of information when you are taking 4 bits. So an example of 4 bit sampling of the signal shown in red color. This image shows that 16 possible combinations can be made from 4 bits. A very low dynamic range in the equality. So what we are doing is we are taking based on the number of bits. So if the number of bits are 4, we know that 2 power 4, which is nothing but 16 levels. So 16 possible values can be made. So dynamic range specifies in the linear PCM, the maximum dynamic range in decibels is given by 1.76 plus 6.02 m, where m is the number of bits per sample. So increasing the number of bits per sample increases the data rate. That is, data rate is given by D, which is equal to Fs into M, where Fs is sampling rate in samples per second, M is the number of bits per second. So based on this, D is equal to Fs into M. So generally, what is meant by rate is bit rate, or the rate is bit rate is the number of bits or the number of bit intervals per second. This means that bit rate is the number of bits sent in 1 second. So in PCM, how you will take the bit rate is, in PCM you will take bit rate as bit rate is equal to sampling rate into number of bits per sample. Number of bits per sample. So in this we will take whenever you are going to bit rate. Suppose that in 1 second, if you are transmitting 8 bits, so 8 bits per second we call it as. So that will be maintaining using a time level and the amplitude level. So if the number of bits are 1001, 1001, so these are 8 bits. So the number of bits transmitted per second. So for 1 second you are transmitting 8 bits. So this is nothing but bit rate, we call it as. Bit rate specifies the number of bits transmitted per second. Bit rate is the number of bits bit levels per second. This means that the bit rate is number of bits sent in 1 second. So bit rate refers to the amount of data, specifically bits transmitted or received per second. So bit rate is given in terms of kilobits per second or megabits per second or gigabits per second, we call it as this. This is a bit rate capability that has been transmitted. So what is meant by bit rate and what is meant by baud rate? Bit rate, as we had known that bit rate is the number of bits transmitted per second, whereas baud rate specifies the number of symbols changed per second. So what makes the difference between these two is uh, bit rate means number of bits that have been transmitted per second, whereas baud rate specifies number of symbols changed per second or number of symbols transmitted per second. So whereas bit rate, it cannot determine the bandwidth, baud rate can determine the bandwidth. So generally bit rate is used for processor efficiency. Okay, efficiency of the processor will be given by bit rate. Okay, bit rate is nothing but the number of bits per second transmitted per second. So baud rate specifies it is used for data transmission over the channel. How much amount of data is transmitted over the channel will be known by baud rate. Baud rate is given by bit rate by the number of bits per signal unit that has been given. So what is the relation between bit rate and baud rate? It is given by log n base 2, where C is the capacity, that is capacity in bits per second or bit rate in bits per second. S is the baud rate in symbols per second. So here C is equal to S log n base 2 will take. So here what we'll do is, here C, this one will be maintained as C is equal to S log m base 2. So where S is the baud rate in symbols per second, C is the capacity in bits per second, m is the number of possible states. Here I had forgotten to write S. Okay, so C is equal to S log m base 2 will be taken up, where C is the bit rate in bits per second, S is the baud rate in symbols per second, m is the number of possible states per symbol. So in this way we are going to discuss about bit rate, baud rate and the difference between them. So generally bit rate is used for processor efficiency, whereas baud rate is used to determine the transmission over the channel. So you can simply calculate based on the different states, and based on generally what they will give you is, they will give you the number of chains and the bits that has been transmitted per second, and they'll ask you to calculate the baud rate and bit rate directly using this formula, that is C is equal to, here C is equal to S log, C is equal to S log n base 2. So based on that the data will be transmitted, based on that the data will be taking place. So this is about bit rate and baud rate, and you can calculate the data based on this bit rate and baud rate. I think we had gone through what is the process of pulse code modulation, that is how you are going through the pulse code modulation, then what is meant by quantization noise, and what is meant by quantization process, and quantization error means what, and what is the dynamic range, and what is bit rate and what is baud rate we had gone through. In the next session we will go through different pulse digital technique, that is delta modulation. So prior to that, just always remember that whenever you are going for digital modulation techniques, you are having sampling, quantization, encoding. These are the three processes that will be done. Sampling means converting the analog signals into discrete pulses. Converting the continuous signals into discrete signals is termed as sampling. So based on this sampling technique, everywhere in the digital communication, sampling technique takes place, where I should follow the Nyquist criteria. F is greater than or equal to 2 times of Fm. If we are following that Nyquist criteria, Nyquist rate, original signal can be detected at the receiver with minimum amount of distortion. After sampling, we will have quantization. This quantization means assigning voltage levels to the sample signals. Then you have encoding. Encoding means These quantized signal levels will be converted into binary forms. So these are the three techniques that should be done in digital modulation techniques. Whatever the digital modulation technique we are using, these three steps has to be followed. Let's end the session today, and we'll discuss about the rest of the topics in the next session. So until that, remember these topics. Thank you.